In this lecture, we discuss about Jacobian. If u and v are two functions of two independent variables, x and y, then Jacobian of uv with respect to x and y is denoted by Jacobian of uv with respect to xy and defined by Jacobian of uv with respect to xy, which is equal to determinant of partial derivative of u with respect to x, partial derivative of u with respect to y, partial derivative of v with respect to x, and partial derivative of v with respect to y. So this is called Jacobian of two dependent variable u and v with respect to x and y. Similarly, if we have u, v, and w are three functions of the independent variables x, y, and z, then Jacobian of u, v, w with respect to x, y, and z is denoted by Jacobian of u, v, w with respect to x and y and defined by Jacobian of u, v, w with respect to x, y, z, which is equal to determinant of del u del x, del u del y, del u del z, del v del x, del v del y, del v del z, del w del x, del w del y, and del w del z. This is called Jacobian of u v w with respect to x, y, z. Similarly, we are able to define the Jacobian of n variable in the same manner. Now, what is the application of Jacobians? So the first application is coordinate transformation. Jacobians are used to transform coordinates between systems, for example, Cartesian to polar are spherical, ensuring proper scaling and orientation of differential elements. The second application of Jacobian is in nonlinear system analysis. In solving nonlinear systems of equations, the Jacobian metric helps analyze stability and convergence, particularly in method like Newton-Raphson method. The third application is in calculating volume and area integrals. Jacobians determine the scaling factor for volume or area element when integrating over transformed coordinate spaces. The fourth application is in dynamical system. It is used to study the stability and behavior of dynamical system by analyzing eigenvalues of the Jacobian matrix at equilibrium points. The fifth application is machine learning and optimization. Jacobians plays a critical role in backpropagation algorithms and sensitivity analysis in neural network and optimization problems. Now, in this lecture, we only discuss about the 5 applications of Jacobians, but this is not limited to these 5 applications. There are many applications of Jacobians. So now in this lecture, this is all for you. Thank you.